Hello everyone, welcome to NA's Institute, a complete chemistry classroom program. So in this class we'll learn about Rubredoxin. Mainly we will focus on its structure and then we will try to learn about some important roles and biofunctions of Rubredoxin. See, this is the X-ray structure of this Rubredoxin. So as you can see that in Rubredoxin, the iron atom is surrounded by 4 cystenyl sulfur sites. So there is not a single inorganic sulfur present. So all sulfur sites are actually cystenyl sulfur, and in Rubredoxin not a single inorganic sulfur is present. So therefore it is one kind of special structure, like the Rubredoxin doesn't contain any kind of inorganic sulfur. So here as we can see that in Rubredoxin there is one iron atom, and this iron atom is surrounded by 4 sulfur sides. All the 4 sulfur sides will be the cystenyl sulfur. Not a single inorganic sulfur will be present here. So the Rubredoxin doesn't contain any kind of inorganic sulfur, and it is the simplest bacterial inorganic sulfur protein which is referred to as Rubredoxin. Here the protein chain is folded to create a tetrahedral cavity by 4 cystenyl moieties, at the center of which ion resides. It will be in either in +2 or +3 oxidation state, and it is again an 1 electron transport agent. Why 1 electron? Because see, in ferredoxin also we have already learned that that the ferredoxin acts as 1 electron transport protein. So like the ferredoxin, this Rubredoxin also acts like this 1 electron transport agent, involving the couple Fe3 plus by Fe2 plus, in which both these Fe2 plus and Fe3 plus oxidation state iron remain in high spin states of tetrahedral geometry. Why high spin? Because we have already discussed these kind of things in the class of this ferredoxin. See that these iron atoms resides in a tetrahedral geometry, and as we know that this tetrahedral splitting is much less than the octahedral splitting, and again these iron binds with the sulfur, and these sulfur are actually weak field ligands. So because of these two reasons we can just comment on the overall splitting of this tetrahedral diagram, and therefore the all over splitting will be less as compared to the octahedral splitting, and hence it will result into a high spin tetrahedral geometry. Now I will comment something about on these iron 2 and iron 3 oxidation states. Now when this iron will be in +2 oxidation state, so it will have an electronic configuration of E3T23, and when it will be in +3 oxidation state, it will have an electronic configuration of E2 and E2T23. Why this? From where these E and T2 labels come? See, when you will just split the d orbitals in an octahedral geometry, so it will split into 2 levels. The lower level will be called as E, and the upper level will be named as T2. Now when it will be in a high spin state, the Fe2 oxidation state will fill these E level by 3 electrons and the T2 level by 3 electrons, whereas in case of this iron 3 oxidation state, the electrons will be filled up like E2 and T23. So here again it is the X-ray structure of this Rubredoxin, and you all know that in the structure of this Rubredoxin, iron atom binds with these 4 sulfur sides, and all these 4 sulfur sides are actually cystenyl sulfur. Not a single inorganic sulfur is present in this Rubredoxin moiety. But actually I wanted to mention here one important fact about this Rubredoxin, and that is this Rubredoxin is generally designated as 1Fe0S. Why this 1Fe0S? Because 1Fe means that one iron atom is present per protein molecule of this Rubredoxin. And why it is designated as 0S? Because not a single inorganic sulfur is present in this Rubredoxin moiety. Now the electron exchange rate in Rubredoxin is tremendously high, and it is approximately 10 to the power 9 electron transfer per second. Do you know why? This is mainly due to the oxidized form of Rubredoxin, where iron is present in +3 oxidation state, and the reduced form of this Rubredoxin, where iron is present in +2 oxidation state. And these two forms, that is the oxidized and reduced Rubredoxins, are actually very much comparable. Here it is important to note that this aqueous iron 3 plus and aqueous iron 2 plus couple, in these aqueous iron 3 plus and aqueous iron 2 plus couple, the electron exchange rate is very slow, where this iron oxygen bond length in these aqueous iron 3 plus and aqueous iron 2 plus differ considerably. It has been proposed that in Rubredoxin, the ligand imposed distortion renders the HOMO neither strongly bonding nor antibonding, thereby facilitating the electron transfer. Now, in Rubredoxin, the iron is actually tetrahedrally surrounded, but the geometry of this Rubredoxin is not perfectly tetrahedral. Actually, it is the distorted one. Why it is the distorted one? Due to this radii difference in between this iron in +2 and +3 oxidation state. Now here, the sulfur iron sulfur bond angle varies in the range from 104 degree to 114 degree. And these iron sulfur bond distances range from 224 to 233 picometer, and when this iron +3 is reduced to iron +2, there is a slight increase in the iron sulfur bond length, which is almost 5 picometer, and the reduction potential of this iron 3 plus by iron 2 plus couple is about 0.6 volt at pH equals to 7. So thank you for today's class, and in this class we have already learned what are actually Rubredoxin. We have already come to know about the structure of this Rubredoxin, its biofunction also, and we have already learned that why the exchange rate in Rubredoxin is actually tremendously high. So basically, once again, thank you for watching this video, and if you have any doubt regarding this class, you can directly contact us through the website www.energinst.com, or you can directly mail us at energinst@gmail.com, or you can directly call, message or WhatsApp us in the given number. Once again, thank you and see you in the next class.